Hi everyone, and welcome to my presentation. The topic of my presentation today is Blueprinting Universal BIM Data Framework Part 2, Seamless Interoperability. Firstly, I would like to thank BIM Coordinator Summit for providing this platform and to share my experience and insights. This topic is actually in extension to my previous BIM Coordinator Summit presentations, where I have focused more on Open BIM and how we can enhance the BIM productivity and the processes. The main essence of this presentation is to take the basic idea of the blockchain concept and then apply it on how we use BIM today. Starting off with a brief introduction about myself, my name is Utkarsh Singh, and I have over 7 years of experience in the BIM industry. And mostly my career has been focused on the interior design, contracting, and the manufacturing industry. Currently, I work at Hurst Bedner Associates, delivering a high-end hospitality, residential, and commercial designs. We are based in Dubai. Throughout my career, I worked on diverse projects using various softwares, engaging in different stages of design and construction. This experience has actually made me question the conventional BIM processes and how we work and how we interpret BIM in today's world. I believe Open BIM combined with blockchain and distributed ledger technology for change management offers a revolutionary solution to solve all the loopholes and inefficiencies in the processes that we have today. These technologies ensure transparency, accountability, and security across the project stakeholders while promoting better collaboration and streamlined workflows. I would like to set up a few definitions of key terms that I will be using in this whole presentation, starting off with BIM data framework. In terms of BIM, a data framework is essentially a structured process that guides how we organize, manage, and utilize data to complete our projects and during our project life cycle. It includes standards, protocols, and technologies necessary to ensure that data is consistently collected and stored and shared among all project stakeholders. A well implemented data framework allows interoperability between different software platforms and different consultants and different stakeholders. This alignment with industry standards guarantees the quality and security of data, which is crucial for the success of any BIM project. Ultimately, a strong data framework empowers teams to optimize the design, construction, and the operational parts of the construction process and delivering a more efficient and a better collaborative approach. What you see on my screen right now is on the left side is a generic common data environment platform that we use today, or at least how it is interpreted in today's BIM projects. Common data environment we widely use on our projects are the softwares that are very vendor specific and do not actually attract or approve of different file formats. So in significant they have significant limitations in the way we manage the data. Current environments often support only a limited range of file formats, which is very difficult to achieve a full collaborative process. And additionally, the lack of direct integration with BIM authoring and analysis tools means teams are still transferring files manually, which leads to a lot of inaccuracies. Through this presentation, I aim to paint a picture of an ideal common data environment which will overcome these barriers by supporting a common native file format and works across all platforms and integrating directly with BIM tools using APIs or plugins or any other process. This would enable seamless data exchange, a real-time collaboration, and automated workflows, reducing the need for manual intervention, which is the cause of a lot of the errors that we observe in today's projects. The solution lies in adopting an open data framework. Such a framework would allow for better model integration and disintegration, improved data consistency, and automated processes. It will also make the BIM more adaptable and future proof, enabling smooth integration with any new tools that are coming up or might come up in future. and technologies as they emerge. By moving forward, open data frameworks, we can make BIM more efficient, collaborative, scalable, and driving the next level of productivity in the industry. Moving on, I've tried to picture how and why we face issues in today's BIM processes. Here are some key issues with conventional BIM process highlighted through the images. The first image illustrates the challenge of interoperability between the softwares. For example, in different phases of the project, we might use different softwares. For example, in the concept stage, a designer might be using a SketchUp or a 3ds Max model, which needs to be transferred to a Revit model on the BIM stages when we start detailed design, or IFC stages, or in the contracting process when it goes to construction. So currently we don't have this interoperability. So the SketchUp model can only be used as a base or a reference, but cannot be actually utilized in the Revit model itself, which might lead to a lot of information loss and misinterpretation. Um, so in the second image, you see that how the change management takes place in the current processes, addressing complications that arise during the BIM process, especially when multiple teams are involved and models are continuously updated. Current changes are modeled and communicated through 2D markups or redline drawings, which is an imprecise and subjective method. There is no formal change ledger or tracker in place for these communications. This highlights the need for an open BIM data framework where the final image you see on the bottom of my screen shows how when we move through different stages of the project involves different consultants and individuals with their own preferences. This leads to substantial information loss and misinterpretation at each stage, contributing to discrepancies between the digital information that we have created at the end of the project and the product that is going to be built. This challenge is significant barrier to achieving a complete digital twin, which as a construction industry, as a whole, we want to achieve a digital twin where everything can be automated and the process is very seamless. All these issues and loopholes are significant barriers. Moving on, as we mentioned that a lot of the elements and the components that are owned by specific consultants and stakeholders in the project, the ownership of a lot of the materials, documents, and the processes are not just specific to any consultant but are shared. The current system creates an obstacle for other parties who do not own the element in the model or in any document, very hard to maintain or record or change anything they want during the project. We can take an example of how a wall finish, say marble, for example, which is a very like common material. We can take this example. How this thing has, how marble has a distributed ownership and is not specific to any one consultant in a BIM project or a construction project. We see that designers who prescribe the finish have information in form of cut sheets or spec sheets, which is a PDF format, which moves on to go to visualizers and renderers, which again have this information in form of a JPEG or a SketchUp model or a 3ds Max model, which is a complete different format. This information goes to the Revit team or the BIM team that starts modeling the project, and this information is saved with the BIM team in a Revit format. From the Revit format, from the BIM team, when it goes to the consultants of the project, they use this information in an Excel or a PDF or a Primavera software, which again goes to supplier, which is again some sort of PDF or information saved on a document. And when it actually goes to construction and the facility management stages, the format of the file is completely different. So when we have multiple formats of the same element with different consultants in the project, it is very hard to maintain any changes and record any changes. And each consultant might have a complete different information, which might lead to a lot of misinterpretation and inefficiencies. Eventually, with many loopholes in the BIM process, be it miscommunication, misinterpretation, or mishandling of data, there is a dire need of developing a conceptual framework and minimize the loopholes as much as possible. Conceptual framework incorporating blockchain technology can significantly enhance BIM process, addressing the key issues. So, as you can see on the left of my screen, the image shows how a framework can be divided into different levels and how data can be managed on each of these levels. So, the first level is essential data extraction. As we know that there might be an enormous amount of data, and each consultant and stakeholder needs the information only specific to themselves, and they don't need the whole information about the thing. So data extraction is a very important aspect. A blockchain technology will ensure that the extraction and cleaning of BIM, GIS, and sensor data are accurate and tamper-proof. Each piece of data can be recorded as a transaction on the blockchain, maintaining an irreversible record that supports reliable asset management. The second level, as we go, we can see which is data storing and data processing, which can be referred to data integration. Using blockchain in combination with graph databases will allow for the effective storage and management of diverse data types. Blockchain's decentralized nature ensures that data integrity is maintained, while graph databases facilitate seamless correlation and access to interconnected data, improving the efficiency of the project. The third stage, as we see, is data processing and data analysis, which can be also achieved by blockchain technology, where enhanced data analysis by providing a secure and transparent trail of data changes and updates. This transparency combined with advanced analytical techniques enables the identification of critical patterns and trends, and data driven decision making is supported by reliable historical record provided by the blockchain. So, on this level, the data that we are storing and analyzing can not only be used for this particular project, but also can be used on different projects further down the line, where you learn from your lessons and do not make the same mistakes that were done in the previous project. The fourth and the final level is accessible data interoperability. A blockchain based platform will provide a secure, user friendly interface for visualizing and utilizing data by ensuring data integrity and providing a transparent record of information. And blockchain enhances data sharing and interoperability across different systems and stakeholders. This will actually further down the line improve facility management and the operation stages of the project as well. Overall, integrating blockchain technology into the BIM process offers a more secure and transparent and efficient approach to manage the whole information and to like store and analyze complex information, ultimately leading to an effective and informed decision making in the asset management and the construction process throughout. So the blockchain-based BIM is basically how we can incorporate the blockchain technology and the concept not only on the invoicing and the payments part of the project, but also on the change management during the design and the construction process. Integrating blockchain BIM, distributed ledger technology, and smart ledger processes has the potential to transform the construction industry fundamentally. By leveraging blockchain, we can gain irreversible and immutable records of changes and data and design, which ensures accuracy and builds trust among all the stakeholders throughout the project lifecycle. DLT, which is distributed ledger technology, uh, enhances the real-time updates, decentralized data management, and fostering better collaboration and eliminating any discrepancies between teams and stakeholders and consultants. Ledgers, smart ledgers or smart contracts, that is very common in the blockchain concept. Automate can automate actually the key tasks such as documentation and contract management, streamlining processes and cutting down on administrative overheads. This powerful combination creates a unified, transparent, and efficient network or framework for managing construction projects, leading to faster delivery and fewer errors and significant cost savings. Embracing these technologies not only enhances operational efficiency but also can pave the way for new era of innovation and reliability in construction. So what you see on my screen on the left hand side in the gray color is the issues or the errors that we have been facing in the current BIM process. The central portion, which is the yellow color points, which are the merits of how blockchain based concept and blockchain based concept has to offer. And on the right side in the blue color are the pointers how this blockchain based concept can help us solve the problems. Incorporating these new changes in BIM will address critical challenges in construction such as data integrity, transparency, and traceability. Unlike traditional methods, which often suffer from data loss and inefficiencies, blockchain provides a robust framework for managing employer information, which we refer to EIR or BEPs or design management plans, and aligning them with supplier and contractor deliverables through smart contracts. This approach creates an irreversible record of graphical models, non graphical information, and documentation, ensuring accuracy and accountability. Blockchain's transparency facilitates automated compliance and code checks, while its traceability features offers detailed provenance for forensic analysis and risk management by integrating blockchain concept with BIM. We enhance collaboration and control, transforming how data is managed and decisions are made, leading to a more efficient, reliable, and transparent construction process. So what you see on my screen right now is I have tried to draw a base level of how open BIM, blockchain concept of BIM, and distributed ledger technology can be incorporated to make a very seamless BIM process. Component level data exchange is a game changer for the construction industry, delivering unmatched accuracy and transparency and efficiency by converting each BIM component, which you see on the bottom of my screen, which are blue blocks. Can so each BIM component can be converted into blocks, which are secured digital token, and recording it on an immutable or irreversible blockchain ledger. We ensure every detail from design to documentation is reliably tracked and cannot be changed, cannot be reversed, edited, or mishandled. Smart contracts automate compliance and trigger critical actions such as approvals and payments based on real time data and milestones of the project. This approach ensures that all stakeholders have access to most current information, fostering an improved and efficient BIM process. Blockchain's traceability capabilities provide a clear history of each component, allowing for swift resolution of issues and validation of the compliances. Extending this technology to supply chain management further enhances precision by streamlining component tracking and automating financial transactions. Adopting blockchain BIM not only revolutionizes data exchange but also sets a new standard for efficiency and reliability in construction. This is the end of my presentation. With this, I hope to reach out to learned BIM professionals and industry leaders who are dedicated to bring positive change and shaping how the BIM processes should work. I wish to spark a conversation and discussion amongst BIM professionals about this topic. I would like to thank the BIM Coordinator Summit for providing such a platform. And any questions, comments, or suggestions are most welcome. Thank you again for hearing me out. And please, I would love to have any questions. Thank you.